Hi, grade 9s. Today we're going to go through the sources of electrical energy. So this is going to be lesson 4.5. And it'll sort of lead into our next section. So we've sort of talked about static electricity here. And now we're going to get into current electricities right away here. But first of all, we're going to talk about sort of where do we get electricity from? Like, where does it come from? So, for example, in Manitoba, when you flick your light switch on, when you plug in your phone or your computer, whatever, where does that electricity come from? So some people you will know, right, that it comes from hydro, right? Well, what does hydro mean? What is that? So we're going to talk about that this lesson. First, though, we're going to start on a smaller scale here. So what are these things that I'm putting up here? Yes, they are batteries, right? But the fancy name for them, electrochemical cells. So anything like this is a battery. These are referred to as electrochemical cells. So electric and then chemical. So it's going to come from chemistry is where commonly called batteries. You can put that in there. These are dry cells that are commonly called batteries. So that's your first fill in the blank there, batteries. Okay, so electrochemical cells. Examples of this. So this is AA, AAA, C, D. We've got our lithium batteries now for phones, that kind of stuff. So wet cells are ones that contain a liquid like sulfuric acid. So for example, a car battery would contain sulfuric acid, so you got to be really careful with them. So car batteries, so I'm just looking at the fill in the blank things there. So car battery is what you're filling in there. Non-rechargeable, put that in, non-rechargeable cells are called primary cells. So if it's a battery that you can't recharge, we would call that a primary cell. If it's rechargeable, it's called a secondary cell, okay? So rechargeable batteries, those are secondary cells. Now, advantages, good things and bad things, advantages and disadvantages, good and bad things about having batteries. Advantages, they are portable, right? We can take them places. We don't have to be constantly looking for an outlet and plugging something in, right? So the batteries, the electrochemical cells are portable, and relatively speaking, they are not that expensive to run. Now, disadvantages, they use resources. So environmentally, they're not friendly. They're a non-renewable resource largely. Pollutes landfill sites. They're expensive for continuous use. If you're this is kind of old-fashioned now, actually. You probably don't see AA batteries, for example, all that much anymore. But for example, if you had a AA battery, like having to replace those all the time, if it's something that uses, oh man, I remember. So funny, the world has changed. I remember having a Discman. I'd play CDs on it, and you'd run out of batteries so much, and it would just cost so much money to always be buying batteries. But that's not your reality anymore. So they don't have a lot of energy before running out. So usually they're small, right? So they don't have tons of energy stored in them. Okay, photoelectrical is our second type here. So photoelectrical, looking at this, you can see what these are, and these are solar panels. Yeah, so anytime you have solar, some of you may actually have solar panels on your house. It's becoming more and more common here. So, wrong button. So photoelectrical, so Einstein explained this effect in 1905, and this later led to his winning the Nobel Prize in Physics for his work in this. So basically light, that's what you're filling in there. Light strikes certain materials, and electrons are given off by the material, creating, creating a current. Those are your 3 blanks to fill in there. So basically, when the sun, when sunlight hits those solar panels, you get. Hold on one second here. Yeah. So you've got a solar panel, you've got the sun here. So when that hits them, you get electrons that bounce off that solar panel. And if we can harness those electrons, that becomes current electricity for us. So a common application is the photocell. So you're going to see these in your solar-powered calculator, that kind of stuff, power generators, security cameras, etc. So a common application is the photocell. That's the one you need to fill in, and I think that's it for there. Now, advantages, disadvantages. So provides electricity wherever light is present. So if you have sunlight, you've got electricity, which is very handy. Some people go camping, they take solar panels with them so that they always can charge their phones or other small devices, that kind of thing. The use of sunlight is free, right? So once you have the solar panel, is free and available. Once you have the solar panel, once you've bought that, the rest of it, there's no charge for that, right? Sunlight is free. Now, small devices can be powered by clusters of photocells strung together, and spacecrafts actually use panels of photocells. So if you see images of spacecrafts, they've all got solar panels on them. Now, disadvantages, energy only in bright light. Now, some of you, again, the world has changed. You would all use your phones now, but if you had like a solar powered calculator, I remember if you weren't like in a bright room, you couldn't like read your calculator. It was too faded. So you do need bright light for solar panels. It's not reliable. So not reliable due to weather. So for example, if it's cloudy, you're kind of in trouble, right? You're not going to be able to harness a whole lot of electricity. Now, the initial costs are also high for that, and a large space is needed. So you'll see them, sometimes you see them in fields, big long rows of solar panels. And it's also limited in high latitudes like us in Canada, because we don't get the hours of sunlight. I mean, particularly now in January, like you guys know, it gets so dark pretty darn early, right? And ironically, of course, we probably in Canada, for example, with our cold weather, we need the most electricity, right? We're high users of electricity because of our climate. The next one's called the piezoelectric effect. This one has to do with crystals. This is an image of it here. Now, certain types of quartz crystals create small voltages when the crystals are stressed. Stressed is what you need to add in there. So if you put force on them, you can get electricity. Now, advantages. This would be like barbecue lighters. So if you have a barbecue lighter and you hear that clicking sound, if some of you will know what I mean, it's like click, 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 click as it tries to light. Those are piezoelectric crystals there. So advantages for this: used for small power apps and portable devices. Crystals vibrate regularly, so we can actually use this for watches and clocks. So when you have quartz, like a quartz watch, sometimes you'll see that on watches. That's this here. Used for needle and record player. Again, record players. Some of you may not know what those are. It's like an early version of a CD. Barbecue starters here. Disadvantages here: not much power, not very efficient. Oops, sorry. So not much power, not very efficient. So this would not be something we would typically use or see that often, right? Oops, sorry. Hold on. Okay, next one, we have the thermoelectric effect. So thermoelectric effect, here we've got two different metals here. We'll talk about that here. So this is when two different metals are joined together and there is a temperature difference between the junctions. When that happens, an electric current will flow. Okay, so two different metals joined together, and where they join up, you get a temperature difference, and that's going to cause an electric current to be there. So we have something called a thermocouple, a device made of two different metals, so copper and zinc, commonly used. An electric current flows due to temperature differences between the metals. Due to temperature differences. There we go. Okay, advantages to this: can be cheap, very rugged, so they're not going to break on you. Used for thermometers and very high temperatures, so ovens. So if you have a thermometer in your oven, well, every oven would, to be able to tell the temperature. They're made of the thermocouples. Now, disadvantages to this: They don't generate much power, so that would be the only real disadvantage here. So doesn't generate a lot of power, not always particularly useful. Okay, so now we're going to get to electromagnetic induction. So this one is our hydropower. So this is what Manitoba uses. Now, what this is, when a coil of wire experiences a changing magnetic field, an electric current will flow in the wire. Let me just see here. I do have a picture. Hold on. Whoops. Okay. So Manitoba uses falling water to move magnets and coils of water to generate power. Hold on. So just looking at the fill in the blank here. So Manitoba uses falling water to move magnets and coils of water to generate power. Okay, so what happens? You've got like a big giant coil. Okay, so if you have a coil of metal and then you move a magnet inside of that coil, you get an electric current. It's really cool. You can even do it on the very, very small scale. Now, but obviously we do it on a really giant scale. For hydro. So we get falling water. The falling water from the dam is going to spin the turbine here. So it's going to move the turbine, and then we're going to collect the electricity from that. And then this is where we get it in wires, right? And these are all our transmission lines. And so when you see hydro lines along the highways, that kind of stuff, that's the electricity traveling from these big giant hydro dams here. We've got a bunch of generating stations in the province. If you were in class, I would show you some videos of that, and maybe we'll do that when you come back, because it's kind of important. I mean, this is what we use in Manitoba, so it's good for you to understand that. Some of you have probably been to the old Pinawa Dam, or Seven Sisters, all in that area. Anyways, we'll talk more about that later. Now, this is called hydroelectricity when we get it from water like this, okay? So nuclear and fossil fuel generators use steam to move the magnets and coils. So electromagnetic induction can be used in many different ways, and even like wind turbines. We're using the wind to move the turbine instead of the falling water, but it's still electromagnetic induction there. So it's the same system, even though you can use different methods of turning the moving the turbine, so turning it, spinning it. Now in Manitoba, we tend to get a little, hold on here. Shoot, hold on. Where was I? From current, there we go. There we go, sorry. Okay, now electromagnetic induction is the most common source of energy. Now, again, there's different ways of doing it. So I'm going to talk about the advantages for hydro here. So the way we do it in Manitoba using the falling water. Like I said, there's other ways to do that. So advantages, once the dam is built, the energy is free. Now, that said, whoops. Man, I am having difficulties today. I don't know how to get this back. Okay, so advantages, once the dam is built, the energy is free. So there's no waste or pollution there either, okay? It's very expensive to build a dam, but once it's built, the energy is free. It's reliable, unlike wind or solar. So sometimes it's not windy, right? But because of gravity, we know the water's always going to fall if there's a height differential there, right? Water can be stored for peak times. So sometimes we use more electricity than other times. We can store the water to get prepared for those. And it can be generated constantly too. So we can run 24/7 if we need to. Oh my goodness, hold on guys. There we go. Disadvantages. Dams are expensive, so that would be one of the negatives. Will flood areas upstream, so that's a big one. We'll talk, I have a picture here. Yeah, so flooding is an issue. So if we look here, this would be what it looked. this would be what it looked like in the past. And because of the flooding, because of a dam being built, this is what it looks like now. So quite different, this particular area. And it can really change an ecosystem and change a landscape. It's hard to find a good site for this. Not everywhere can use it. Like, that's why in Manitoba, we're able to use it because we have a lot of good sites. Like, we have a ton of waterways, rivers, lakes, etc. So it works well for Manitoba. Water quality and quantity can be affected downstream, which can change plant and animal habitat. So this is a huge issue in terms of Indigenous rights and lands. So can be quite controversial. If you look into that, you'll find lots of articles on that, and Manitoba Hydro has tried to do work with various reserves where there's Indigenous people living, and that's their land, and then the city of Winnipeg wants electricity, so we're going to flood all your land so that the city of Winnipeg can be okay. So very controversial. There's lots of different sides to it, lots of different aspects to consider there. Okay, so moving on, we have nuclear power. This is nuclear there. So this would be our nuclear power plants. Good things about it: they're cheap. It's pretty cheap, nuclear energy. No rivers needed. Less damage if everything is okay. So nuclear power plants, if everything goes well, they are awesome. But they have very, very dangerous byproducts. So if things go bad, they go very, very bad. So we have Fukushima. You guys, no, you'd be too young. No, yeah, you'd probably be too young. You might remember somebody talking about it at one point. But we have Chernobyl, which is older. We have 1986 with the Chernobyl disaster in the Ukraine. So there was a big explosion. You can visit Chernobyl now and see what happens. So basically, when you have a nuclear explosion like this, you get lots of radiation, which is of course cancer causing to humans and other organisms. So this would be just devastating here. And again, I would say if you have an interest, you should look up Chernobyl. There's a ton of really interesting, good videos on that, and quite disturbing too. But yeah, so nuclear power, when it's going well, it's great, but if something goes wrong, we have like major problems and potentially a lot of lives lost. And on that happy note, yeah, so now you can do your assignment. You were given, I think, questions, right? So you have 6 questions there on the sheet, and the sheet's called Science 10G, Sources of Current. You can do that. Now you will have a quiz on these concepts on Thursday. We'll talk about this at our meet. Anyways, that's it for this. Thanks, everyone.